Hello everyone, welcome to Smart India Hackathon Designing Digital Solution program. My name is Sakshi Jamgaonkar. I am working with Persistent Systems as technical trainer. I have around 18 years of training field experience and I am working with Persistent since last 9 years. I mainly train on Java J2E technology, scripting languages like Perl, Python, PHP, machine learning, IoT, Arduino programming, Raspberry Pi programming, etc. The entire session of Arduino that we are going to cover is been divided into two modules. As we already saw in the first module, we talked about introduction to Arduino, what are the different Arduino boards available, introduction to Arduino Uno board, Arduino programming constructs, and the entire Arduino hardware details. Now welcome back to this second module of overview of Arduino, where mainly we will be covering some interesting demonstrations on Arduino programming along with lot of sensors connected to Arduino board, and then I will discuss about one of the online Arduino simulator available called as Tinkercad. Okay, then let's get started with this second module now. Let us see the agenda for module 2. We will have a look at Arduino programming in detail, different hardware details, couple of sensors that we would cover: LDR, DHT11 temperature sensor, read switch, PIR motion sensor, and then we will discuss about online Arduino simulator called as Tinkercad simulator. Just to do the recap, in the first module we looked at the detailed hardware of Arduino board. So these were the different components that we looked at on the Arduino board. So this was your Arduino Uno board. We looked at starting with the first program execution by using Arduino IDE as well. The first example that we looked at was LED blink. The LED was connected to the inbuilt pin number 13 and we saw that the LED was glowing. Let's try and cover the same demo by extending the entire circuit on a breadboard. Something like this. So instead of connecting the LED directly to the digital pin numbers here on the board, let's put that on the breadboard. Then you'll have to have a resistor in series to limit the control flow and have that one pin connected to ground and another pin connected to the power. As we already discussed, there are two legs to the LED. The longer one is anode and the shorter one is cathode. Horizontal pins on your breadboard, they are not connected, but the vertical holes are connected. So to one end of the leg, I will take the resistor in connection as series, and the other leg again I will put it in a horizontal same line. You can see that in detail. The basic connection I have kept it ready. Let's look at the program in the IDE. Here comes the Arduino IDE. As we already discussed in the last module, there are a couple of basic examples readily available as documented in this IDE. Let's pick up from basics, the basic blink program. The basic two methods that we discussed were implementing setup method to do the initializations, the one that gets executed only once the Arduino board is powered. Then there is a second method, loop, the one that gets executed repetitively. That is what the microcontroller does the functionality. Here we have initialized the LED pin mode for that built-in LED built-in. So on the same pin number I want to connect that. As we already mentioned, LED built-in is your pin number 13. So I will be connecting that LED one end to 13 pin number. The cathode side will go to ground, the other end of the resistor to go to pin number 13, where we are trying to make that LED on with the digital write predefined method available in the Arduino programming construct. So let's send the high output to that LED built-in so that LED will glow. It will turn on the LED. After a delay of 1000 millisecond, want to put on that LED with the digital write function so that the LED will turn off. Let me complete the connection with this program. This end of cathode should go to ground. And the other end of the resistor should go to pin number 13, as we have used pin number 13 in the program. So what are we trying to achieve through this connection is now the LED should be on and LED should go off after a delay of 1000 millisecond. So this is your basic connection that we extended through breadboard. Now as the other end of the USB cable I have already connected to laptop, let's simulate the program. So simulation is nothing but pre-compilation. Here it is, which is going to verify your code. Alright, the verification is successful. Let's upload this entire program to your Arduino board. The program will go to the board. It will reside in that flash memory that we discussed. The linking of the program will happen to your Arduino board. Alright, here is one error that we see. The point that we had discussed, before uploading the sketch is your typical Arduino 1 program that you are writing, is a sketch. You have to go to the tools option here. Make sure that both the menus board and port are properly enabled. As far as board is concerned, yes, it is showing the selection to our Arduino Uno board, so that's fine. But talking about the port, the selection should be done. Then only the communication will be successful. So let me select this COM10 port and then re-upload once again. Alright. So uploading of the program, burning it to your Arduino board is done. As an output, visibly what I should be able to see that LED is on and off after the specified delay, isn't it? Let's have a look at output. Here we go. LED is on, after a delay it is off, on and on. That's what your this microcontroller chip, that is Atmega 328P, that we discussed in detail as a hardware, the heart of your Arduino board, that is doing this functionality of repeating the code again and again, the one that has been written in loop method of your Arduino programming. That's about the very first demonstration for LED blink. The connections were something like this, wherein we added a resistor in series to the LED. Cathode, which was a smaller leg of LED, was connected to negative and the other end of the resistor was connected to positive, and we completed the entire electronic circuit. And after connecting it to your Arduino board properly and the Arduino board powered up with the supply was drawn from laptop, Arduino board working voltage is 5 volt is what we already discussed. Let's talk about LED fading effect as a second demonstration. Now in the previous example, we discussed about digital write functionality. So digital signal is either low or high in terms of 0 volt or 5 volt. Now I want to talk about something called as analogWrite here. Your circuit will remain the same. I want to have that LED instead of on and off, I want to have a fading effect by sending analog output signal to this. So a little recap on what we already saw with the pulse width modulation. On a pin in Arduino, a steady digital source wave is always generated, going from 0 to 5 voltage. Now since some devices like DC motor etc. need analog signal to run, we need the pulse width modulation to interface them with Arduino. As in, the Arduino doesn't provide you any analog signal outputting directly. For that, PWM tricks the Arduino and simulates a sine wave from a square wave. So in a way, we are trying to get a sinusoidal sine wave here to get you the analog output. Now this is done using pulse of varying duty cycle on the pulse width modulation pins, the pins that we had targeted with the specific tilde sign. So now let us see that how open LED fading works. The PWM is a technique for getting an analog-like behavior from a digital output by switching it off and on very fast and with the different ratio between the on and off time. Because of the persistence of vision, we cannot see that the time the LED was on or off. Because it happens so fast, we get a feeling of LED is fading. This gives us the simulation of a sine wave. So actually we are talking about a digital signal only with the kind of a square wave, 0 and high voltage, that we are trying to get a simulated, getting you the analog signal output. So how do we do that? Going to your IDE here, again one of the existing example will help you to check this. Under the analog section here, we have this fading example. Now here, instead of connecting LED to pin number 13, I am taking pin number 9. When you are talking about the analog signal, you need not initialize the pin mode for that signal. So in this simple example, in a for loop starting from 0 to 255, so corresponding between the range of 0 to 5 digital signal, we are trying to convert that into a sinusoidal value from 0 to 255, wherein I will talk about sending analog signal on that LED pin. So in short, what we are trying to confirm is LED should be connected to the pin number 9, that is my program demand, to the digital pin number 9. That's it. So you are sending an output there with the ranges here, with the so fast effect, with a very short delay here. In a way, I will get a fading effect. Let us see that how. The one that was connected to pin number 13, I am removing that. Here is the pin number 13. Instead of that, we said pin number 9. Why 9? You can use any of the digital pin from here, from 0 to 13, but the one that have been marked as prefixed tilde sign. This will give you that PWM signal on these pins. let me connect the board to laptop. Let's verify the code. Now let's upload after the successful verification. All right. Successful linking of the code has happened to your Arduino board. Arduino board is powered up now with the connection that we have already done. So on the pin number 9, we are sending that analog pulse width modulated signal. So only we are getting an effect of fading effect, as you see here in the LED. So in short, to conclude on this, with a simple example of analogWrite, we could check on that PWM signal, sending it on one of the tilde sign pin of Arduino board. Let's look at the next interesting demo, wherein I will be talking about both digital read as well as digital write. So I am planning to use a push button which will act like a sensor for you now. Whenever the button is pressed, there would be some signal coming to your Arduino board, and whenever the button is released, another level of signal will come to your Arduino board. And with the control of that position of push button, press and release, we want to control the actuation of the output LED. So as already highlighted here in the diagram, the LED we will connect it to some pin number, maybe your default inbuilt LED pin 13, and then have the connection of your push button to the ground. Let us see the connection of the circuit here. Now as you can see here, there is one push button that I am planning to use. This is a push button, pressing and releasing, and through that I am planning to control actuation of this LED. Connections are very simple, straightforward. Let's connect the LED cathode to ground. I am just ensuring the connections here. Anode is connected to pin number 13. Now since I am connecting this LED to the pin number 13 on the digital section here, and since that inbuilt 13 pin number is having a series resistor, I am not connecting any additional resistor over here. So that's fine. The control of the current through the board through that LED will be controlled by the inbuilt resistor from the Arduino board. Now to see the connection of this button, let me highlight it properly here. This push button also has a positive, negative and the data signal. 3 pins are there. So simple, positive and negative will go to the positive 5 voltage and ground respectively, and the data signal we will put it to pin number 2 is what I have selected. This is your pin number 2 beside your RX and TX. Beside RX and TX, the pin number 2 where I am trying to connect this yellow data signal from push button. Let's connect the board to laptop. Now as you see here, I have initialized one LED pin to 13, then push button on the pin number 2 as I have already connected it to pin number 2 of the board. In the setup, the basic thing initialization is pin mode of that LED pin as output. Push button is your like a sensor, so I will have to configure that pin mode to input. And then initially let me put a low on LED pin with the digital write function. And inside the looping, what will be the code? Let's read the signal coming from push button. So whenever it is low, that time we'll see if it is press of the push button will give me a low signal actually. If it is so, that means in the pressed position of my button, I would like to send a high signal to LED so that it will glow. Else, that is releasing the push button, the value might be high, that time I want to make the LED low. Let's verify this code quickly and then upload. With that successful upload, let's look at the output here. Here is your push button. Pressing of the push button has put on the LED on. And I release the button, the LED is off. I do that again. So you are sensing the sensor input from the push button. The moment it is pushed, the signal that I captured in the program, I have sent the high output on the actuation of the LED. So it has glown. Release the button, LED is off. So both the things we did talk about, getting a digital read from the button as an input side, and at the output side sending the digital write on the LED to put it on and off as per the actuation. Let's continue with using some of the common sensors that are available. Here you can think of so many types of sensor available, like for sensing the temperature, I might have a temperature sensor. For sensing the pressure, pressure sensor. For checking the humidity, I have a humidity sensor. For capturing the motion, I have a motion sensor. For checking the magnetic field generation, I have something called as read switch. To talk about capturing the flow signal, I have a flow sensor. So, a lot of sensors that are available which can be used for connecting them to Arduino board. So, here I can define sensors and actuators as transducers. Transducer is any device that converts the variation in a physical quantity such as pressure or brightness into some electric signal or vice versa. So, when I talk about a sensor, what is it? A device that receives and responds to a signal. This is a broader concept that includes the extension of our perception capabilities to acquire the information about some physical quantity. So, as an example, under sensor, I can think of it as an input transducer, example microphone, and the actuator, which is going to be an output transducer, as an example loudspeaker. In the previous example, we picked up a push button as a sensor and LED was acting as a simple actuator wherein we could put on and off the LED as per the digital signal captured by clicking of a button. Let's go through one more interesting demo here with LDR. Here I will be using analog read, serial communication as well as digital write. So, here it is, your light dependent resistor, the component would look like this. Couple of other resistive sensors could be FSR, flex sensor, thermistor, etc. On the LDR, you have a photoconductive material on the top surface as seen here. Depending on the intensity of the light falling on this particular sensor, it will vary its resistor inside. So, if I go for a connection something like this, I will put one LDR component along with a resistor in series. This particular resistor value is constant, which will control the current flowing through it. But if I draw a voltage output in the middle of this series connection, this output voltage will vary whenever there is a change on the resistor value of this LDR. And when will the resistor change of this particular component? As per the change in the intensity of the light falling on it. So, in short, the light level, if it is light, and the values of R1 and R2 as I am highlighting, R1 kept as constant, but the change in this resistor value here will vary the voltage output. Now, according to this change in the output, probably you can take an action, what the actuation that you want to carry on the change in the light intensity. For this, we will use analogRead. This reads the value from a specified analog pin. Arduino board contains 6 analog channels, A0 to A5. This means that it will map your input voltage between 0 to 5 volt into the integer values between 0 to 1023. So, I would be saying analogRead, read from which pin number. Let us see the demo for this. In this again, I am planning to connect LED on pin number 13. In the setup, I am initializing the serial communication so that I want to see the value through the serial communication. So, I start the communication on the serial port with the baud rate of 9600. Then I am initializing that pin mode to output for the LED. Now, I read analog signal instead of digital read. Here it is an analog read from the sensor pin. Sensor pin is connected to one of the analog pin, let us say A0. And then I am checking if the sensor value is greater than some value, then I want to send the digital write high. Else below this value, send a low signal to the LED. Let us verify this, and meantime let me show you the connections. Here is your LDR. This is how it looks like. A very small component. The way I showed you on the diagram, on the top surface you have that material capturing the intensity of the light. I just have to connect the LED also for the actuation. Let me put a LED here. Anode is connected to pin number 13. Anode is connected to pin number 13. Here is the pin number 13. The cathode is connected to ground. Again, for this also we will have ground, VCC voltage input and the data pin. Let us put one resistor in series here, that would be required as I already showed you in the diagram explanation. So, as you can see here, one leg of the resistor is connected to LDR leg and another end of the LDR has gone to ground. The other end of the resistor has gone to 5 voltage, and the middle section that I have pulled out, that is V out that I showed you, the middle section is your V out point, that I have given it to the A0 pin. The blue color is connected to A0 from the analog section. This is the analog section. we have connected over A0. Let me connect the board to laptop. Here is a serial monitor that I had already introduced, wherein you can see the, alright, to upload this again we have to initialize the port. Every time I change the board or a new connection is done, I have to ensure the COM port. Alright, with the successful upload of this program on the Arduino board, I would like to check what analog read value that I am getting on that LDR sensor pin on A0 analog pin. To check that, I have started the serial communication, and as the Arduino IDE provides us the serial monitor here. One thing that you have to ensure on this particular serial monitor, the baud rate at which it's running, here it's been highlighted at the right bottom corner, it is 9600 baud rate, and that's what I have used it in my program as well, while beginning the serial communication here with 9600. If it doesn't match, then probably the serial monitor will not display anything here. Right now the analog value that I am getting from A0 pin, where you have connected the LDR sensor, as per the light intensity that I have here in this room currently, as per that it's giving me the value 1003 or 1004. I'll have to change the light intensity falling on this LDR here, so that I will be able to see the variation. How do we put? Probably putting a hand on this. Light intensity got changed. Can you see that the LED has put on here? The moment there is a change in the intensity again, those are the values that I can show you here. So sometime here it crossed 1023. The moment the darkness was there, the value was getting incremented. And that's what I was checking in my code. If it's going beyond some limit 1021, put on the LED. And if it's below that value, let's say 1003, which is below 1021, the LED is off. So let's have a look at the output once again. I put a darkness on that LDR by putting a hand on the LDR. The moment the value has gone high, above 1021, LED is on. You can see that the LED is on here. I remove the hand from the LDR, light following on is more. Again I put the hand here. So changing the intensity of light falling on the LDR is actuating your LED. Isn't it interesting? So the simplest program that we could do here, just by applying the ready-made constants, some ready-made functions that are available, and here was an example wherein I introduced about a serial value that I was checking coming from an analog value, analog pin sensed by LDR, and then actuating LED by using digital write. Let's continue with one more demo, wherein just now as I discussed about analog read, analog or the serial communication that we discussed, let me show you one example on serial read and serial write. As we have already seen, serial is used for the communication between the Arduino board and a computer or some other devices. All Arduino boards have at least one serial port. It communicates on the digital pins 0 as RX receiver and on the digital pin 1 as a transmitter, as well as with the computer via USB. Thus, if you use these functions, you cannot use pin number 0 and 1 for the digital input or output. Keep them open. Pin number 0 and 1 we are talking about. You can use the Arduino environment's built-in serial monitor to communicate with an Arduino board here. Let's see one demo. Here we are going to connect LED on the pin number 13. Let me just show you that the LED is to be initialized in the output mode, and then I begin with this serial with the baud rate of communication 9600 baud rate. If there is any serial communication value available, then I start reading the value through serial.read method readily available. And that value, let me write it on the same serial monitor just for you to see what the value that I got. If it is 1, I am sending high value to the LED. If the value is 0, I am putting off the LED. So, simple. We want to see that serial communication. Take the input coming from some serial pin, but just for a sampling here, we will take the input from the serial monitor that is available in this IDE and actuate the LED. As an execution to put on this particular LED on, I have to send some serial input. So, let us come back to the IDE here, go to the serial monitor. This particular input field is here to take the serial input. I enter 1 and press enter here. Let us upload the code once. I took the serial input as 1. Going back to the program here, when you check, if the value that you read from the serial port here, the value that has been returned, if that value is 1, we are putting the LED on. If the value is 0, then I am putting the LED off. Need to see that. Is that happening? Yes, with the value 1 entered, LED is on. Let me put the value 0 here. Value is getting displayed on the digital, the serial communication monitor console here. With the entered value as 0, I see that LED has put off. Coming back here, I enter 1 once again. I see that LED is on. Once again, I enter 0, LED will be off. So, with this, I could see one example of how I will be able to do the kind of a serial communication using the serial ready-made functionalities available for Arduino programming. Let us look at one more interesting example here for capturing, reading temperature and humidity signals. For this, I will be using one readily available sensor called as DHT11 sensor. Now, for using this particular DHT11 sensor, you have to get one external library. That external library supporting your DHT11 is available here at a provided link. We need to add that DHT11 library into my Arduino programming. Then only by including that library in the program, I should be able to continue reading or sensing data. So, here we go. DHT11 sensor would look like something like this. Again, this sensor also will have 3 connections, 5 volt, ground and another data pin. Data pin, you can take it on any one digital section pin here, let us say pin number 2, and the remaining here on ground level and 5 volt is been connected. Let us have a look at the code and the output on the Arduino board. Here we go. When I say hash include DHT11.h, this is the external library. How do we get this? We have this particular one downloaded zip folder. There are 2 ways of getting this external library. You can go to the sketch menu, include library. Under this, you have a manage libraries option. Here you can enter the name of the library that you are looking for in this field, and you can search for this. It will go to the open source connection on the Arduino official site, and if that named library, if it's found, that can be downloaded from here and it will come into your required folder. That's one way. Second way, again include library, and if in case you already have a downloaded zip folder, you can say add that zip library. It will take you to your window explorer, pick up the valid zip folder wherever it might be available and get that. Here are these external libraries I have already made available. Having these zip folders available, they can be imported in your IDE. With that, adding a zip folder from the sketch include library facility. I have already done that. So, including this dht11.h will be successful, no error on this. Now, I initialize that DHT11 pin number on pin number 2. So, I am planning to connect that DHT11 on the digital section pin number 2 now. Whatever is the value that will be sensed from that digital pin, pin number 2, after changing the temperature, probably the sensor will give me some different value. And according to that, I want to see that what value is. I would like to see that on my serial monitor. So, I have started the serial communication with the begin method at the baud rate of something 115200. I printed the temperature sensor, whatever is the DHT11 version is available. I just want to print that. In the loop, what am I doing? I start reading the value coming from that DHT11 pin, where I have connected that to the pin number 2. Read the value, and whatever it reads, that DHT11 will have the stored value. Through the constants of DHT11 library, the humidity will print the humidity, it's in percentage, and the temperature in Celsius, I am printing that with the float value, it's getting printed here. All that printing of the sensed value, for now, to showing you, I am doing that printing on the serial monitor. Alright, it's giving you some kind of a display of garbage value. The reason is, the baud rate at which I started serial.begin is a different value. So, I have to have that value set here at the bottom right corner. Here, let me change this to the one that I have used in my program. Here we go. It printed that version that I was printing, and then it started printing the values of humidity and temperature. So, currently in my room where I am sitting, here the temperature looks to be 24. Now, what I will do, I will show you at the output level. Just remember here, currently 40 and 24 is getting displayed. After a delay continuously in the loop, it is again and again the microcontroller is sensing the temperature, printing it. After some delay, again sensing, it is printing. So, showing it on the circuitry level, this is how your temperature sensor look like, DHT11. So, it has the pins plus, negative and data signal. So, in all 3 wires are coming. I have connected them to an appropriate ground, VCC, and on the digital side here, the data pin is connected to pin number 2 I have used. Alright. Now, I will hold this particular digital temperature sensor. The moment I hold it, this will have the variation in the temperature, isn't it? I am holding it. So, humidity also will be there and there will be a change in the temperature. Hey, can you see that? The values are getting changed. Temperature is getting increased, 25. I will not see much of changes here right now because its AC is on. Having it in a kind of a realistic environment, you can observe the change in the temperatures. So, all in all, a sample example we are checking here. This DHT11 sensor is really useful for the kind of a POCs if you want to develop, where the temperature, humidity capturing you want to do, and according to the range of temperatures that you are looking for your POC, you can actuate something probably again the LED or any other action you want to take it on the transducer output side as the actuation, that can be taken care. So, this was a sample example understanding DHT11 for capturing temperature and humidity, and I try to display that here on the serial monitor. Now, you can think of on a broader level, probably you can send this data to a kind of some LCD display what the temperature is, or you send that to a cloud side wherein according to the temperature value you want to take some kind of action there. All those could be your realistic examples, prototyping you can develop. The next one interesting sensor I am introducing is read switch, wherein I will again go back to using the digital read method. What is that read switch? The read devices are electronic or electromechanical components that work using technology of read contacts, realized for the first time by Bell. How does it work? When the device is exposed to a magnetic field, the two ferrous material inside the switch pull together and the switch closes. Here it is. This is your read switch. So, if you bring the magnetic field near this, the ferrous material inside the switch pull together and the switch is closed. And when the magnetic field is removed or taken away, the read separate, the switch is open. So, you can just take a sample POC here. If this read switch is connected to a door and I want to control the sensing of that, whether the door is open or closed. So, depending on the magnetic actuation there, magnetic field coming near to here, I would say that it is a closed position. So, I will conclude the door is closed. If it is taken away, that means the door is getting opened. In that case, the magnetic field is off. Let us see one example of this. Here again in the setup, we have started the serial communication at the baud rate of 9600. We have initialized the pin mode for that read pin in the input, so that I can capture that magnetic field related signal coming. Let us do that digital read on that read pin. Read pin is going to get connected to the pin number 2, as I have already defined at hash define read pin at the pin number 2. So, here read pin variable is understood that it is connected to the digital section pin number 2. As a sensor side reading that particular value, I am printing whatever is that value. If it is 0, then I say that the magnetic field is generated and it has closed it. So, the door is closed is what I am concluding. Else the magnetic field is taken away from that read material, then the door is open is what we want to conclude. Right now it is displaying door is open because I have not taken any magnetic field near that read switch sensor. Let us apply the magnetic field near it. This is how your read switch look like. Taking the magnetic field near, here this is one of the magnet that I am using. I am taking a magnetic field near this. Here it is. I have taken a magnetic field close. Here it is, it's in a closed position right now. The moment I take it away, it's open. So, isn't it interesting? By using this simple one sensor, just getting connected to your Arduino board is allowing you to have a magnetic field signals checking in your Arduino programming, and accordingly you can think of actuation of any other output transducer. So, this was your simple read switch connection the way I showed you. There is one more sensor called as PIR motion sensor. It is a pyroelectric or passive infrared sensor, what we call it as. This typical sensor contains a pyroelectric sensor that generates the energy when exposed to heat emitted from the objects nearby. So, this is a simple dome shaped sensor looking like this. Let us look at one demo for this. Alright. So, in this example again I am connecting the LED on pin number 13. Input is on the pin number 2. We are setting those pin modes on LED as output and input pin as input. Just would like to check the values on serial communication, and in the loop we read the data coming from that PIR sensor. We can put the value digital write as high on the LED pin, and I keep checking that value, and then I say that the moment there is a change in it, I print that motion is detected. Let us see one demo for this. Alright, this is your PIR sensor connected appropriately with 3 of the pins, positive, negative, a data pin to the pin number, I am using pin number 2 here on the digital section I am connected, and there is a LED. The moment there is any change in the motion, these motion sensing are very sensitive, so capturing the signal might have some delay. Can you see that? So, the moment there is a change in the motion, the object coming in front of this particular sensor is changing that LED on to off. So, it is able to sense the motion through that PIR sensor. The same value could be seen on the motion detected here, the one that I am printing. I can show that on the serial monitor as well. One thing that I showed you was through LED display. So, with that, last sensor that we covered was PIR sensor. Let us talk about some external shields that we can attach to Arduino. So, what are the shields that we have already talked about in the first module that provides us the extra functionality, which can be stacked on the top of each other. Couple of examples of shields could be GSM shield, which looks like this, Ethernet Wi-Fi shield. Let us say this is the board. As the original Arduino Uno board does not have the inbuilt Wi-Fi capability, you have to have a external provision for it, and the one that can be achieved by putting this additional shield stacked on the top of your Arduino board. You may also think of a simple example here as one of the LCD shield. You stack this board on Arduino board and any signals that can be captured here, and you can have a LCD display. So, GSM shield is for a international standard for mobile telephones. It supports the outgoing and incoming voice calls. Wi-Fi shield, the wireless communication that you want to send it through the Arduino, this shield would be required additionally. So, with this LCD display, let me quickly show you that one stacking on. Hey, here is this simple connection. Can you see that there is a stacking? This is a way I can show you in a better way. This is your original Arduino board, and I have stacked the additional shield supporting the LCD display. The pin configurations and all, they exactly match. The pin configurations match here. So, only we are able to stack it exactly on the top of Arduino board. And here we go. Here is the LCD display. Hey, can you see that the hello world is getting displayed on this LCD? So, you can think of a on-field some POC you are developing, let us say temperature is getting sensed, and at a remote somewhere that device has to be installed and continuously the temperature has to be monitored. So, you can have a LCD display wherein the DHT11 sensor that I showed you, whatever the temperature we sensed, that can be displayed continuously here. So, all your that the on-field device need not be connected to laptop every time. If it is being powered by using a power jack, you just have a kind of a individual component and the entire circuitry developed as a POC connected to the in-field device, which will keep displaying this. Here it is. Getting that LCD display, we need to use one library. That library is called as liquidcrystal.h. Again, these are all the ready-made sample examples which are available in the examples category. That needs to be initialized with some appropriate pin number parameters that you need to pass. The documentation will tell you all this in detail. In setup, I just executed a begin method and then say lcd.print, which will print a message to the LCD. That's it. But this particular printing, I am doing that probably repetitively with these two methods executed and where I want to execute and print that. This we could achieve with the extra shield that we have connected on the top of your original Arduino board. The stacking is what we have done. So, two boards can be seen. So, these kind of shields give you the extra facility functionalities on the top of your existing functionality of Arduino board. This is about a little introduction on what are the shields. Now, let us continue with the very last part that I have to introduce you. For simulating, you have one online simulator available. The name of that simulator is Tinkercad. It has a popular CAD package that runs in your browser and provides the feature for building and simulating virtual Arduino circuits. There are a variety of components you can add to your design. You will find an integrated code editor and a debugger as well. You can even get the serial monitor all in your browser with no actual Arduino hardware. So, for the first time after this session, when you want to play around Arduino board with lot of hardware components, see how they work, what kind of a code that I have to put in, you can just play around this Tinkercad simulator without the hardware availability. Only the one prerequisite, you have to sign up, create an account at this official site tinkercad.com. Since I have logged in already and created an account, I can show you. Here is the home page of this Tinkercad. Here under the circuits category, you can think of creating a new circuit or open up any existing created circuit. These are all the circuits that I have created already. Let us say create a new circuit. I click on that. Here, as you see on the right frame facility, you can just search for Arduino. Can you see that the Arduino Uno revision 3 board has been picked up? Just drag and drop here in the blank window that you see on the left hand side. Isn't it? It looks exactly the same as the hardware that I had shown. Digital pins, analog pins, power section, heart of the Arduino board, this chip, USB cable, USB port, reset button, power jack, all just the same as your hardware that we already saw. What I can do is search for one simple LED component. Can you see that the LED has come? Let me drag and drop here. Automatically it highlights, this is cathode, this is anode. Anode has to go to, let us say, built-in pin number 13. I connect it, and cathode to ground. Conventionally, cathode wire, jumping wire should have a black color. What all that we are trying to do is simulate the circuit here same as your actually the hardware that you had connected. Now I'll simply say start simulation. Did you see that? With the start simulation, the USB cable got connected here and this LED is blowing. Why? By default it's blowing since it's connected to the pin number 13 and it's an inbuilt LED which is connected. So you can see that the inbuilt LED is also on here. After having this particular visualization of the circuit, can I go to the code tab here? I clicked on it. Let me stop the simulation. Stopping the simulation, it has removed the plugin. Under the code blocks here, pick up the drop down text. Let's say continue. Hey, it has highlighted the code. Isn't it familiar to you now? The setup method, loop method, using that digital write on the default pin number 13, all that I could do this. Going back to the home page, the one that I created just now has given some different name here. You can go to the properties here, options. You can, under the properties, you can save that with whatever the name you want to give, save that circuit. And likewise, you can play around with lot of by default available components. Different boards that are supported here as Arduino board is supported. If I see the under components tab here, let's say go for Arduino. Hey, it has given lot of ready-made examples already with the Arduino board connected to a breadboard. You can drag and drop that particular component and see how does it work. All that basic learning stuff with the button, how is the button connected, how is the LED with the resistor connected, all this we can just drag here, play around with it, see the code automatically gets generated. You can export that code, get it into your IDE that we have been working till now, and there you can do couple of changes as per your actual hardware, the ones you get the actual hardware. So isn't it interesting? So first time learning, definitely you can start going through this very simple and interesting online simulator that is available called as Tinkercad. So here it was a little introduction on that. This is how it looks. Here we see the output also. Alright, with this we have come to an end of our second module on Arduino programming. In this session, mainly we discussed about Arduino programming, different Arduino programming constructs, then all the hardware detail connections, along with the sensor learning. Different sensors that we talked about were LDR, digital temperature, DHT11 temperature sensor, PIR sensor, read switch sensor, etc. And then eventually we did discuss about Arduino simulator called as Tinkercad. Here are some of the useful reference links for you. Hope you found this entire session interesting and useful. Thanks for attending this session. It was great pleasure teaching you all on this platform. Wish you all the best and thank you everyone.